Okay, hey, welcome back to The Good, the Bad, and the Techy, a podcast all about leading edge technology. I'm VP of Engagement, John Collins.
I'm CTO, Howard Holton.
And this week, what we want to do is cut through the jargon and give you what you need to make sense of it all, in this case being all about everything to do with proxies, load balancing, getting whatever the application's trying to do in there, out there to people's desktops and other servers, et cetera, et cetera. Delighted to welcome you, Liam, from NGINX. Maybe you could say a little bit about yourself and maybe a little bit about NGINX and what it is.
Thank you, John. So yes, I'm a Senior Director of Product Management at NGINX. So I look after all of our open source and our commercial products. And I've been an individual contributor product manager since I joined NGINX in 2015. And at this stage, I'm kind of 5 years into the sort of post-acquisition life within F5. But I can kind of chart my kind of experience with the web and web servers and proxies, unfortunately, all the way back to 1993. So it's been a journey.
I thought the web started in 94.
Well,
no. Well.
It did get popular from there, but actually I think 91 is when HTTP 0.9 or the
was it really? There you go.
But yes, I was, let's call it an early adopter. I had a website. I actually had a web app in 93 with actual code. So, but I had time on my hands. I was at university, and the university didn't have a website, but security wasn't really a thing. So you could just basically throw a website. What you were doing, and I've just been building incrementally, one thing on top of the other ever since then.
Wowzers!
So one of the things that I like to say, and you kind of just touched on it a little bit, right? When all this stuff started, we didn't think about security at all, right? Security was something the telcos had to be responsible for. Security was something the banks and banking systems had to be responsible for. We didn't have the massive amount of interconnectivity that we have today, right? They were mostly closed networks, mostly closed systems. We of course didn't have any idea of being able to interact with your bank in 1991 via a website. But today, I would say, I like to say that there are only two things every business must compete in, whether they want to or not. The first is the currency system of any country that you operate in. And the second is cybersecurity, right? I can choose to do just about anything else. I don't have a choice over those two things. And the reason I add cybersecurity is because it is a combat sport. If you choose not to field a team, the opposition is still fielding a team, right? You just lose instantly.
Yes.
And that kind of brings us to NGINX, right? The last 10 or 15 years, I'll be honest, ever since COVID, I can't keep track of the number of years before COVID. As far as I'm concerned, it's still 2019. So let's call it somewhere between 10 and 15 years. NGINX has been a part of my stack universally. And when I talk to other IT people, DevOps people, software development people, home lab people that have a decent appreciation for technology and run it themselves, NGINX is like, I don't know, Teddy Ruxpin. It's a beloved piece of technology that we look upon fondly and just simply trust. Right? I've never encountered anyone that's like, oh, I tried that NGINX thing and I don't like it. Right? However, much like security in the last 10 years, what NGINX is NGINX is not a product, but a whole suite of things, right? It's a whole solution set far greater than the reverse proxy that most of us are aware of.
Very true. And you're right about, dead right about the security aspect. And I think, as you mentioned, for the more sophisticated practitioner, they kind of understand that NGINX is something that you can pretty safely put in front of internet-facing things. So whether it's a simple web server serving out some files that you want to share, or whether it's sitting in front of a web application that's actually doing some business logic, NGINX is very often the tool of choice for the thing that's going to actually stand out there and face the ravages of whatever might come at you across the web. And yet it's not really positioned as a security product very much. Certainly in the community, you don't really think of it as a security tool, but it has its characteristics are such that it can stand an awful lot of traffic, an awful lot of bad actors, an awful lot of sort of abuse and misuse of standards, and basically deal with it and behave well without exhausting resources. And it's one of the many benefits you get from being. It has a really strong design goal to minimize external dependencies. So it doesn't suck in a ton of libraries, or other people's code. It's very, very tightly curated. And there are only three. Like, it doesn't roll its own crypto, right? OpenSSL or SSL or compatible library is there. A zlib compatible compression library and a regular expression library. The end. That's it. And so when it comes to supply chain, all these other sort of dimensionality of security, they are, that attack surface is very, very small, and it implements its own everything else, basically.
And I'm going to pretend to be the person that knows nothing about this area whatsoever, just for the audience. You understand that it's entirely to represent people out there, and I'm completely lying. But my view, I mean, NGINX is a kind of request wrangler, right? You send an HTTP request or an HTTPS request out there, and it will hit NGINX first. So anything, whether it's a good request, a bad request, an intrusion attempt, whatever, it'll all come to you. Is that pretty much it? And then you're kind of managing what happens next.
Call it front door, and whether that, and that's why many CDN services are built on NGINX too, because it's got that inherent robustness and scalability, and at the same time, due to the technical library things I was talking about, means that it's very small. It's lightweight.
Yep.
And I think gets back to what Howard was saying, right? And one of my favorite anecdotes about NGINX, not really anecdote, is that if you've got something which is lightweight and high utility, it can kind of go anywhere. So think like a rugged little 4x4 off-road Jeep, right? It's
it's a Suzuki Samurai or a Jimny, if you're
exactly
not
something like that. Right? Something like that, yeah. So hop and skip over. You can basically put it anywhere, and it will do useful things. That's so being lightweight, being as small as is necessary, and being high utility is this is now a 20-year-old project. From when it was originally open sourced, it was very, very. It didn't do a whole lot of stuff for the first half a dozen years, but
it's also an open source project that's easy to get up and running. It's easy to maintain. It's easy to run. It's easy to manage, right? Like the evolution of the platform has been as much in ease of use, I think, as anything else, because your average IT person can run it in their home lab with no resources and not expend a lot of time, which has us all kind of complain, as part of your educational journey, right? As part of your kind of movement from ops to DevOps, movement from whatever to whatever, or a software development that has no experience in infrastructure can also run it, right? So it's one of the few pieces, one of the few tool sets that sits in between kind of your traditional IT operations people and your traditional software development people, and works for both, which I find to be also impressive.
That is very true. And NGINX has a somewhat unusual relationship with developers. It's often considered part of the developer toolchain, and yet it's plumbing, it's infrastructure. It sits between a web client and and usually a web application, some code, and it sits there and does a bunch of stuff that makes both people's lives better. You get a good, secure, solid, stable connection. If you're a web browser and you get basically your web application gets to see the most perfectly behaved client it's ever seen, because
that's true,
right? It takes all of those wrinkles out. I mean, and it allows for some of the somewhat shonky HTTP implementations that are sitting there in app servers and other kind of app dev engines to get away with it, because you've got something very robust in the middle. So it's that shock absorber. Like, it takes all the the rubbish you can throw at it, allows you to do some stuff in the middle, whether it's slowing down requests, rate limiting, caching, acceleration, routing, rewriting URLs that someone got wrong, whatever it might be, and then throwing it out to the back end, and the back end gets to see this not just perfectly behaved, but extremely fast.
It feels more like a smart letterbox than a front door. Although I recognise that we've gone down the 4x4 analogy route as well. So, but it does. But so I'm kind of thinking. So we're done. Great. Thanks, Liam. And tune in next time. But I mean, so what's causing dynamism then? What new things is it having to deal with? How is the world changing? How is it changing?
Well, one of the increasingly challenging sort of engineering problems with NGINX is as the web evolves and new standards come along and new protocols get implemented and new security regimes and expectations go up, the complexity of running an NGINX deployment or infrastructure stays pretty much the same, and that is by design. So in the last few years, of course, the most recent example is the emergence of QUIC and HTTP 3. So we've been through HTTP 2, we're now at HTTP 3, kind of actually quite quick succession as standards go. And if you want to enable HTTP 3 on your NGINX instance, you just basically type that at the end of one of the configuration lines, and it's there. You don't, there's literally as simple as that. And we go to great lengths to try and keep the configuration very stable, right? Very, very. You don't get breaking changes on upgrades very, very rarely. And that comes along. So keeping up with standards, keeping up with TLS, all the security requirements, and picking the right moment when the default value of something needs to get ratcheted up a notch so that it's secure by default, without dissolving the administrator of responsibility to configure it for them. Their security stance. Always a trade-off between compatibility and security, right? You can turn up all the ciphers, all the protocols, all the security stuff to the max, and every time you do that, you start shutting off older clients, older phones, older computers. So that's down to the administrator.
Security is always a trade-off between usability.
Yep.
Right. And anyone that doesn't think that it is, or anyone that argues against that, I would caution, it really is. You have effectively said this is the limit of security, because any further than that affects usability. But the truth is, security always affects usability, right? It's friction by design.
Yep.
Right. So kind of one of the long-term values of NGINX is I trust NGINX, so I don't have to trust everything behind it, kind of thing. Right. If we use that front door analogy, that screen door, because NGINX gives me such a reliable front door experience, I can put things inside the house that I don't have as much knowledge of their supply chain, that I don't have as much trust with, like the 1,000,001 things I'm doing with Docker, Kubernetes, containerization, cloud native, whatever you want to call it. And yet I get the confidence, because I've got far more control over that traffic than I would otherwise, that those things are not going to bite me as bad as they potentially could.
Yep.
Right. So that also kind of leads NGINX down a path of, since that's likely what all of us are doing with it, right? You guys have also looked at how can you help continue to support that by adding features to NGINX. And I may be putting words in your mouth, as in that may not be the logic that you used, but I think the destination is still the same, right?
Yeah, so the goal is to provide the most valuable, lightweight, high utility front door for your application traffic. So that includes Kubernetes. So as the so things that we're doing around that. So that's why NGINX is by far the most popular ingress for Kubernetes, for the front door for a cluster. And as that sort of technology evolves, and there's a new Kubernetes standard with the gateway API for how you control traffic in an cluster. We sort of see a responsibility to build the de facto implementation of that on with NGINX under the hood. So these are the things that we spend time on building out, and there's a misconception or a popular preconception that NGINX is an eponymous web server, whereas closer to the reality is that NGINX is actually an open source organization with a commercially funded by F5 that has multiple open source projects. It's just that you only heard of one of them. So partly because we don't do a great job of talking about them very well, but but I mentioned two already, right? There's the ingress controller project, which is, of course, NGINX doing the plumbing, the network traffic under the hood, but it's got an open source controller, the Kubernetes at the front. That's how you do your YAML configuration to tell you how your Kubernetes services, how to route traffic there, and our implementation of the gateway API in our Gateway Fabric project. So there's another NGINX open source project. And then if you want to extend NGINX and do stuff that you're just not going to get out of the box, you need to do something custom, whether it's you got some cookie stuff to do, some custom auth, you have to integrate with some legacy backend. You can write code in JavaScript and have it run inside NGINX, like as middleware. And so there's another open source project with a full JavaScript implementation that again follows the same DNA, where there's no minimizing external dependencies, minimizing weight. So you can run we actually run a full JavaScript VM in the context of a request and then destroy it at the end of that request. So you can do all sorts of things like that.
I mean, this isn't a question, but I hear about all the other open source projects as well, and I'm thinking about Service Mesh and Istio and all that sort of thing, and the way that the different cluster groups talk to each other across the distributed environment. Do you just slide into there, or do you replace things, or how does that work?
Yeah, so we toyed with Service Mesh. We had an experimental project, Engine Mesh, I think it was called. We're going back a bit now. That really wasn't, at the time, it was a bit early, and actually Ingress is covered 80% of what you needed to do. It's still largely true, actually. And since then, we've sort of decided to focus on the gateway API as opposed to managing all the east-west traffic. Because ultimately, my view is that I think that was a very heavy solution to a problem that very few people had. And I think that the eBPF is going to be the right way to do that.
Okay.
West control. So it's something that we experimented with. The project's still there, but it's not actively maintained. And we think that there's got to be a better way of doing that than basically hanging sidecars all over the place.
That makes sense. That's yeah.
So talk to us about eBPF. What is eBPF, and what do we expect to see from it? And how does NGINX look at it?
Great question. So eBPF essentially is a way of programming the kernel. So it allows you to write your own custom code and for it to run inside the Linux kernel, which means it can run anywhere. Pretty much in any pod or containers, Linux based. You can put some custom code in there, and that solves a lot of problems for needing to do stuff at the network level, because all that network traffic has to pass through the kernel. That's the way that the Linux operating system handles networking, and you can now intercept every time something happens on the network. It's a very elegant way of doing fine-grained control of traffic inside containers, because otherwise you end up with a myriad of containers. The way that NGINX looks at eBPF is Well, we've got all of
let's sit on eBPF for a minute, right? Because I do think it's important that people understand, right? eBPF is fundamentally a massive change in potential performance, but also security. Right? Being able to add security into the kernel within eBPF also gives us the ability for endpoint management that we didn't have before, without some of the heavy performance overhead that we had in prior solutions. Right? Part of the value to eBPF is running in the kernel mode, running at the kernel level, gives us a potentially massive increase in performance. Now, that does, of course, require your vendors to write software accordingly. Right? Anyone that's going to operate in there. And then at the same time, it's likely a place where we're going to have to pay attention. Right? I don't want malicious code running in eBPF, in other words.
Exactly. It's double-edged sword. So you're granting kernel level privilege to some software. And that is great because it's running in the kernel, so it's faster and you're not switching in and out of user mode and kernel mode all the time. But you need to make sure that you've scoped that function that you're bringing into the kernel to do only the job that it's supposed to do, because it's running in this elevated privilege state. I was just thinking of we actually use eBPF as part of the HTTP3 implementation in NGINX. So we had so we look at it as another tool in the toolbox when you're writing system software for a Unix, Linux operating system. You've got a bunch of system calls you can make through the operating system to the underlying hardware. So networking being the obvious case. And in the case of HTTP3, it's built on the quick transport, which is built on UDP, which has a different set of a limited set of system interfaces with the Linux kernel. So the challenge being, this is a little more technical than
That's okay. Go for it.
We can come back up. That's fine.
Yeah, so the challenge being, with TCP, you've got a fixed connection from client to server. With UDP, you don't. You just fire packets around, and you hope they get there, and if they don't, you have to deal with it. But Quick, on top of that, essentially is sort of reproducing that end-to-end connection, and we need to maintain a session. But there's no such syscall in the Linux kernel that brings you that, because UDP stops at the packets firing around. So we implemented in our HTTP implementation for Quick an eBPF function that simulates this next level up, so that when we can sort of maintain state, and when Quick's got some really nice security features built into it, like you can move around from cell tower to cell tower, or on and off Wi-Fi, and your IP address can change and doesn't matter.
Right. Well, that's the value to Quick, right? The value to Quick is I literally can't do those things in TCP. The only way to do them is UDP, but UDP has all of its own problems. So Quick sits on top of UDP to give you service reliability you previously only got with TCP, but the mobility that UDP provides, kind of. If I try to sum it up in the most simple possible way, right? It's part of what makes things like Quick so hard to explain. It is very technical, but in an effort to make it a 30-second elevator pitch. Yeah.
Are you thinking it? Well, we really need to build a whole new transport protocol, but we can't. So we'll use UDP and bolt stuff on top, because inventing the whole new transport protocol is not possible at this stage.
So we could also further define that. Technically, it's possible. However, the internet would start all over.
Yes.
Right? Because the transport protocol is what the internet runs on. And therefore, in order to change it, every single piece of the internet would have to adopt it for it to be ubiquitous. So instead, we stick with what is already ubiquitous, because we're not going to rebuild the internet from scratch.
That is a more accurate statement. Yes.
So I'm just thinking about, I'm not at all thinking about, oh my God, how deep are we going to go on this? And rather, I'm also thinking about MPUs and DPUs. If you can offload some of that networking traffic and some of that kind of initial processing traffic and take it away from the CPU, and then what's the impact on the Linux kernel setup and so on and so forth, and how are you managing that? But before you answer that, or even think about that, because we could keep going down, do we then end up with just more architectural options than we had? Because the whole thing comes about, it's ultimately going to be all about scalability. All right. Sort of scalability versus security. What you're trying to do, if you've got a tiny little website that with minimal traffic, none of this matters. If you've got a retail website and every microsecond counts, then you really want to get this stuff right. So it's how you architect for that. Is that fair?
That's very fair. And I think what you touched on there is, if we just reflect back on the eBPF conversation, it's like, okay, you can go in either direction. You can optimize and offload at the hardware, or you can, and write some custom code that runs there. Or you can do the same now in the kernel. And as you frame that up, John, what options do I have? Well, I think it depends where I want to run my stuff. And if I'm not speccing my own hardware, I probably, because I'm running in the cloud, then I probably want to go towards an off-the-shelf, or if I have to, extend with more software and eBPF in the kernel, unless sort of the XPU stuff proliferates to the point where I can pick up any of these. I'm going to hook back into something you said earlier as well, which was about ease of configuration. Mm-hmm. Because if you give people every single option, you go, there you go, off you go. It can all be amazing. People will just go, and they'll default to the easiest, which is going to be the least good for all the scenarios that you might have. So the more you can make it easier to configure, the easier it becomes to do harder stuff easily. That's very true, but I think there's also an element of exoticism. So, like, do I really need an exotic solution that requires custom hardware, or a custom Linux kernel, or even need to inject software into my kernel? I really have to have a strong, painful problem to want to do that. Because if we think about the ubiquity of the Linux application stack and everything on top of it, and HTTP as a general purpose transport protocol, there's not a lot you can't do with that. There are plenty of people who have problems, who run up against challenges there. And you've talked about retail, of course, financial services are always a great use case for where every microsecond counts. But you need to be in one of those extreme environments to go and stretch that, I think. But or you're running at such, you're not exotic, but you're at such scale that it's a cost thing, and the offloading in one direction or the other gives you a measurable decrease in costs that's worth being a bit more special in how you construct your application stack and how you deploy and where you deploy.
For sure, but for 99% or more of organizations, don't do that.
Yes.
Right, like listen to good advice. Don't do that. Right, and really, if you think you're one of those organizations, you're not. Right, if you know you're one of those organizations, the decision's already made. If you think you're one of those organizations, you're not. You know what I mean? Like, at this point, you've already reached that scale. It's not a question of right. You're already unique. It's not a question of maybe we're unique enough to demand that. I like playing with new stuff.
The danger is, I hate to say it, but the danger is in the engineering layer and the architects who would really like to be working with organizations.
For sure.
And will be the champion of the exotic solutions.
I was literally going to say that. Yep.
It's 100% true, right? At the leadership level, though, your job is to serve the business, and you should know 36 months out if you're going to reach a turning point, right?
Yep.
Like you should know 36 months out, hey, something's going to change, and our traffic's going to look much more like Amazon than it does today. It's going to look much more like, a major telco. It's going to look much more like Cloudflare. It's going to look much more like insert name of company that has that kind of scale where that matters. And if you don't see that as the leadership, make sure that your people aren't over designing for it, right? The general rule is I have 100 milliseconds to retain someone. So from button click, I have 100 milliseconds to retain them, not 0.1 millisecond, right? So when you're looking at your stack, look at optimizing your stack for that 100 milliseconds and always aim for the low-hanging fruit.
Mm.
Stop aiming for the exotic.
Absolutely.
Right. So within the context of that, like what is kind of your big takeaway that you'd recommend kind of leaders think about when they're looking at optimizing that stack? Is there some best advice with NGINX? If they've already got NGINX, where do you suggest looking next? Like what would you kind of give them as a solid takeaway here?
Well, I think some generic advice to which NGINX applies is if you make sure your stack is portable, like you could run it anywhere on any cloud or multi-cloud or on-prem or all of the above, then you've got some inherent flexibility. So avoid the exotic from your preferred supplier and from your internal technologists. So if you can't pick up that stack and redeploy it somewhere else very, very easily, then you've got too much going on in that stack.
So like many times we go back to Einstein, right? Make the solution as simple as possible, but no simpler. I think that was Einstein that said that. If I'm wrong, someone in the comments is welcome to tell me. I'm happy. Yeah.
It sounds like good advice either way.
Right, but it's good advice, right? Make it as simple as possible and no simpler. Don't aim for the exotic, in other words.
Yep. And again, it also reminds me of that sort of NGINX philosophy of lightweight and high utility. So does the thing as simply as possible, and if you get that right, it by implication will be portable. It still surprises me to this day that NGINX, it currently isn't, but it was number one. It was the number one image on Docker Hub. When containers went crazy and we had Docker Hub, it's currently now it's in the top 5, I think, or the databases are killing it. But anyway, if you exclude the database, it's still right up there. Not one line of code was changed. Not one packaging change happened at NGINX for it to fit in that environment because it was lightweight and high utility. And to this day, that's still true. And it's remarkable how often it's used as the Docker demo, because you just run it and it says, hello, welcome to NGINX. You've either seen welcome to NGINX or you've seen
for sure
NGINX 500 or something because your backend's down. But that's usually
for sure. And I think as kind of a big takeaway, that's a great one for leaders, kind of looking at your tech stack in general. Lightweight, high utility. Right?
Yeah.
So aim for lightweight and high utility. I mean, that advice applies to database, right? Web server, database, virtualization, your container platform, your optimization platform. How do I make it as lightweight as is reasonable and as high utility as is reasonable? Aim for those 2 targets first, add on from there.
And I hate to say it, but it's going to apply to your AI-powered applications too.
Oh, it absolutely is. Right. Especially because high utility and lightweight is still a matter of exponents when it comes to, AI, right? The cost of not aiming for those within AI will be millions, whereas the cost of not aiming at it with your database is likely to be thousands or tens of thousands. Right? Like the scale of that decision is going to rapidly, it's like it adds commas. So I think that's excellent advice for leaders looking at their tech stack, trying to figure out what the next steps are, and constantly under the barrage of review, right? Lightweight and high utility.
Can't go wrong.
Be more NGINX.
We should really start doing some marketing.
Amazing. Thank you so much for coming on, Liam. It's been brilliant.
Yeah, great conversation. Thank you.
Yeah, this has been another episode of The Good, the Bad, and the Techie. As always, like, subscribe, share, comment. If you'd like to see a technology featured, let us know. If you'd like to come on the podcast, let us know. And Liam, this has been fantastic. We'd love to circle back and have you on again in the future.
Let's do that. Thank you.
Right. Thanks, everybody. And we'll see you on the next episode.